Good morning, everyone. Thanks for joining us here at the Vail Summit, the 28th Annual Vail Summit. I'm Mahip Mandloy. I lead the renewables and clean energy coverage here at Credit Suisse. With us, we have the honor of hosting Aqua Metals with us this morning. I have Steve Cotton, CEO of Aqua Metals, and Judd Merrill, he's the CFO of Aqua Metals. I'll let them talk more about Aqua Metals, but briefly, they have developed a technology, a different battery recycling technology, which in the past they've been using on the lead batteries, and now moving on to the lithium-ion batteries. Just to quickly introduce Steve here, Steve Cotton has served as president of the company since May 2018, and he was promoted by the board of directors to the president and CEO in January 2019. Steve has also served as the Chief Commercial Officer for the company from 2015 to 2017. Prior to joining Aqua Metals, Steve was the co-founder of Canara, formerly Data Power Monitoring, in December 2001, and served as its Chief Executive Officer through the sale of the company in 2012. Thanks, Steve, for coming to the conference and doing this call with us.
Thank you.
And Judd joined Aqua Metals in November 2018, right? From Klondike's Mines, a Nevada-based international mining company, where he was Director of Finance and Accounting. Judd was responsible for overseeing the SEC compliance and the management of the company's $200+ million budget over 5 subsidiaries. Welcome, Judd.
Thank you.
So I briefly gave an introduction on Aqua Metals, tried to frame it in as less words as I could. But yeah, would love to hear from you. I think you have this nice blue box over here where you kind of show what you do, how you separate the different metals or elements from the battery materials. But yeah, would love to maybe give an introduction from where does Aqua Metals fit into this broader battery supply chain, and how do you compete with others in the market here?
Yeah, so the world is very focused now on electrification and transition to new energy, and a big part of that, of course, is the batteries that go into electric vehicles, as well as the batteries that go to energy storage systems that we see in incarnations such as solar farms, wind farms, home energy storage, grid stabilization, and even data centers that have 100 megawatts plus of power in those facilities. So where are we going to get all these batteries to manage this electrification and have all this battery energy storage, both in the electric vehicles as well as those other applications? And that's really become the lithium-ion battery. There's different chemistries of lithium-ion batteries that are out there. The key to it is the multi-metal environment that goes into a lithium-ion battery is pretty significant. And the common metals that are in there is, of course, lithium. And then there's cobalt, and then there's nickel, and copper, and manganese are pretty much the primary critical battery minerals, we'll call them. So today, those critical battery minerals are solely sourced from mining sources. And that's common when you're building a new industry. Now, if you look as a student of history, as we are, because Aqua Metals also has a technology to cleanly recycle lead batteries. Lead batteries have today 90% or so of the lead that's in those batteries came out of an old battery, got recycled in a closed loop. If you look at lithium batteries today, right around 0% of the metals that are in the new batteries came from an old battery, and that's what's got to change to make this energy transition sustainable and worthwhile to address global climate change and all those things. So what Aqua Metals is focused on is developing the cleanest way to recover all of these critical battery minerals and do urban mining as compared to earth mining. And then ultimately the earth mining, as the lithium battery industry matures, will feed the cumulative annual growth rate of these critical minerals. And as students of history, again, if you look at the lead world, lead acid batteries is still a $65 billion industry, and 99% of those materials are recycled. And as I said before, 90% of the metal that's in those batteries came from another battery. So how do we close that loop cleanly? And what Aqua Metals has invented and now is the only company in North America that has a pilot plant that's continuously running that produces these critical battery minerals in a unique way. And what's unique about our method is there's three ways to recycle batteries. One is called smelting, and that is where you use high temperature furnaces, and you don't recover any of the lithium, for an example, and you put a lot of pollutive things in the air. Smelting is one of the top 5 most pollutive things that mankind does on Earth. So with smelting, you're kind of going to end up moving a problem as we try to get off of fossil fuels and get towards battery energy storage, and you want to really solve the problem. So then there's hydrometallurgical methods that talk about, we take chemicals, we leach it through the broken apart batteries, and then we create various materials. There's challenges associated with that, both economically and environmentally. It's from the mining area, very common. You take ore, you put it on a pad, you leach chemicals through, and then you get the output, and then you have a bunch of waste streams. And that's expensive and impactful to the environment. What AquaRefining from Aqua Metals is different is that we actually do electroplating, and an electroplating coupled with a hydrometallurgical process that recycles the chemicals in a closed loop, and we also extract the metals in metal form, and we're the only company in the world that does that. And what I have in this blue box is it's like one example, like this is nickel, and this is cobalt I'm holding up here in metal form, and then copper. So these are the 3 metals that we actually selectively plate, and we know that we can make new batteries from metals as a source, because that's how we make lithium-ion batteries today. But one of the key ingredients is lithium hydroxide. And so this is native to our process, and we pull out the lithium hydroxide all at very high yields, so the economics are really good. And the source for us, the input for the AquaRefining process is called black mass, which is what I'm holding in my hand now. It looks like black sand. And that is an industry in and of itself where companies collect used and spent lithium-ion batteries. They store and transport them safely, and then they crush them, and they create this, which is the amalgam of all of those critical battery minerals that I was showing you and talking about earlier. So Aqua Metals' pilot plant is operating today, and we've just announced a few weeks ago a campus environment that's all taking place in the Tahoe Reno Industrial Center. And that's about 30 minutes east of downtown Reno, Nevada, near the Tesla Gigafactory and many others that are out there. And that campus environment is going to take our pilot operations that we're currently running and getting learnings from and get that to a capacity ultimately of 10,000 tons per year, which means about 100,000 EVs worth of battery materials recycled out of that facility. Or another way to look at it is about 420,000 home energy storage systems. Think of a Tesla Powerwall. So that'll be the initial capacity of that campus environment that will step function stage towards to get to that 10,000 tons over the next couple of years. So it's a really exciting time for us at Aqua Metals as we embark upon really being in the lead, we believe, of creating all these minerals and building a campus environment that will allow us to scale to a couple $100 million plus worth of revenues in that time frame.
Gotcha. And for those who obviously can't see what's in the blue box, I think on your slide deck, I think on one of the slides, I think slide 11, on the latest one, you have just showed all these
the pictures,
right? So
yeah,
that's useful for anyone who wants to go on the ir.aquametals.com, right? But so you talked about a lot of things there. So let's start breaking out all of them. So first, on the urban mining versus earth mining,
yeah,
right? That's definitely an important reason to kind of switch to recycling. But what else is the driver out there for customers, like from a cost point of view, or like, or supply chain point of view, or geopolitics point of view? Like, is there enough demand for recycling right now, and also supply? Like, where do you get the feedstock of these batteries?
Right. So on the demand side of the equation, I would say there's an insatiable demand for these minerals. It's not a day or a week goes by that you don't see an exciting product announcement of a new EV, a commitment by a major auto manufacturer to completely electrify by X year, as well as all the battery energy storage applications, drones, VTOLs. I see a picture of an interesting VTOL right in front of me.
Yep.
And those are lithium powered. So there's all kinds of cell makers and cell pack manufacturers, and then ultimately the end use builders that are trying to find all these minerals, which are scarce. And the demand curve is very rapid, and mining takes time to catch up. So if you want to open a new lithium mine, for example, you have to go through major permitting processes, and you have to go through probably 5 to 10 years time frame to get to scale. So how else do we get those minerals? Well, we reuse them after we dig them up out of the ground, and we find a way to redeploy those minerals back to the lead acid battery world, where it's 90% of the minerals in those things have already come out of the earth and been used over and over and over in an infinite loop. So the demand side is definitely strong and going to continue to grow. And there's debates about what the price point of cobalt and lithium hydroxide is going to be in the future, and nickel. But we know it's not going to probably go down a lot. It's probably going to go up as that demand drives it. And then on the supply side, it really is an interesting time where the supply today for new batteries that are being made that are lithium-ion batteries is almost primarily 100% from the mining world. But as the recycling capacities begin to grow, that is going to become more and more of a piece of that supply equation. What's also interesting about the supply side and the recycling side is, what does the world want to build the infrastructure of the future if we look out towards 2040 or something like that? Do we want to build a bunch of smelters to move the problem of electrification from fossil fuels and still have a bunch of pollutive outputs, or do we want to build the right infrastructure back to solving the problem? And that's why we're so focused on the environmental impact of the way that we do the recycling, is because we're trying to make sure that the world builds the right clean recycling infrastructure, so when this industry matures, we actually have really solved a problem.
Gotcha. As we think about the supply of the feedstock over here, where do you get most of it today? Is it the consumer electronics, or do you have start seeing these bigger batteries yet come in? And like what I'm trying to also get is the closed loop requires a lot of effort from the industry to kind of make sure it's a closed loop, right?
Yeah.
To make sure things are recycled.
Yeah.
Does that take time to build up?
It does, and so there's a tidal wave ultimately of spent EV battery packs that is coming. Already, like the early Teslas and the Nissan Leafs, and even hybrid, plug-in hybrid type vehicles, those packs are coming back. But a big part of it today are things like the Ego leaf blowers and the cell phones that we all burn through a battery once a year. And amazingly, to get the highest performance, they have the most cobalt in them. So for example, one iPhone battery has quite a bit of cobalt in it as compared to an EV battery, and about 147 iPhone batteries makes a whole EV battery when it comes to the cobalt ingredient. And so the lower tonnage of material that's coming back for the urban mining world is richer today than it will be in the future with the EV packs, but the EV packs will make up for that in just sheer volume and weight. But it's a very healthy industry today, and our sources of this black mass material that I was holding up earlier, which is the input to our process, are multiple. And today that black mass, if it doesn't come to us, typically goes to smelters. And when they smelt the black mass, they don't get any of the lithium out of it, but they do get some of the nickel and some of the cobalt and things like that. But there is a supply, and it is growing, and will continue to grow. And it's a kind of a space race, so to speak, of building the infrastructure in time to be ready to handle the higher volumes.
Gotcha. And then I want to touch about the smelting or the different technologies over here. But just on the previous point, in this race, like, do you need, or what does the industry need, either from the government or policies or regulations? Like, what kind of supercharges this recycling going forward?
Yeah, that's a really good question, because never before in my lifetime, and probably in a couple of lifetimes, have we seen such government support for a transition like this. So the electrification of the world is as big of a deal as bridges and railroads and the steel industry and transportation to begin with. And the government did plow into those types of things. But now with the bipartisan infrastructure law and the IRA and the Defense Production Act and other activities that the government is getting involved with from the DOE's perspective, as well as, believe it or not, the USDA that supports the Rural Business Development Fund to create made in America plants that have American workers in rural areas, all looking at this space and applying loan programs as well as grants. And that's an exciting thing for a company that, like us that's looking at how do we finance the build-outs, because not only can we do that with capital markets and equity, because we are a publicly listed company on NASDAQ, one of the few companies, by the way, that you can actually expose to this space because some of the other players are private. The government support of this industry is really underpinning the growth. And if you look at the last round of grants, about $2.8 billion was handed out to most companies in the ecosystem by the DOE outside of the recycling space. And this next round of funding opportunities that's happening this year is going to be more focused on the recycling space. So, of course, Aqua Metals is very interested in very closely working with the DOE and these other organizations to help fund the growth of this. And I don't think that the industry would be able to grow as fast without that funding. The other part of it is policy that you mentioned. And so that is key when you look at by 2028, the percentage of North American or NAFTA-sourced materials, such as all these metals, have to be in the new batteries that are produced, whether that's mined or recycled. If you recycle it, that's an even better story and a marketing angle for anyone that's wanting to talk about the recycled content of their batteries. But those policies are making a big difference. If anything, the U.S. is being viewed as being very dominant so far in government funding and policies, to the point that the Europeans are saying, well, wait a minute, what about us? You guys are going to try to become the next Saudi Arabia with the new energy world, et cetera. So it's going to be interesting to see what kinds of policies and funding we see from other countries. And I hope that we see it all over the world, because every part of the world needs to have access to their critical minerals, because if you don't, you are subject to what outside of your borders can do to control your market.
Right. And I think there was this news this morning on Bloomberg that China is clamping down on lithium production from one of its regions in Jiangxi province. So that might take away 10% of global lithium. So probably needed more than ever, right?
Yeah.
But just going back to the technologies, the smelting or the pyro technology, which is probably, as you said, mostly what everyone uses, so that's where the black mass goes to. And they are also getting at least so far, the DOE loan programs also, right? So could you just talk about like the difference in, I don't know how to put it, but the technology or the scale of the technology between your technology and the pyro technology?
Sure. Yeah, so today about 5% of lithium-ion batteries are even recycled. The 95% go into the landfill. The 5% that are recycled are at scale today, at any level of commercial scale, it has been smelting. And the challenge of the smelting is not only the environmental impact of the smelting itself, but also the transportation of these batteries to the smelters and the carbon impact of going across continents and oceans, and then back continents and oceans back to secondary processing of those materials. And so that's a definite challenge and that capacitization part. We won't see likely a lot more smelters built, because we're seeing policies again say you can only recycle unless you recover a certain percentage of the minerals, and smelting not recovering any of the lithium or ever being able to recover the lithium, because it rather burns it and it goes into the atmosphere, which isn't a good environmental or economic outcome. That will be more difficult to permit and build and grow that capacity. So hydrometallurgical and then our method of AquaRefining are kind of going to be taking over the capacity growth, and that's what we're seeing, huge amounts of investments in those types of capacitizations. And starting with thousands of tons per year of output per plant, getting to tens of thousands of tons of year per output per plant.
Got it. And then maybe the question for Judd probably, as like how, as you ran through this pilot factory here, like going forward, how do you think about your capex needs, and with all the incentives in the IRA, does that help with any of those, and how should we think about the profitability targets going forward?
Yeah, no, that's a good question. You know, we've pretty much funded the pilot operations with the cash that we have, and we've been able to maintain a healthy cash balance through all of that. You know, as we looked forward to expanding and seeing the return on investment and the higher revenues coming in from that investment, you know, we're looking at what are the sources to fund that CapEx expansion. And Steve alluded to some of those when he talked about the different opportunities out there, the DOE loans and grants. The USDA provides a note for where we're located. That's up to $25 million. There's some different tax abatements that are offered in the state where we're located. So all of these are things that we're looking at and will be sufficient or more than sufficient to get us to that next stage, which is our demonstration facility. And so those are the things that we're looking at in terms of just expanding that growth. And once we reach that demonstration level, we'll start generating good revenues. Will help fund additional growth. But the larger grants from the U.S. government are 50 million to 100 million plus. We've seen some even larger than that. And those are things that we could see help us in that next stage, kind of that next phase of growth.
Gotcha. I'll just briefly pause there to see if there's any questions from the audience. Others I can go in on my end. Okay. Sorry, Amy.
Just a broader question on, you know, we hear a lot about battery recycling here, but the bottleneck always seems to be the scalability and understanding how to achieve that. Is there a path forward, like how do we achieve scale on this?
And just for the audience on the webcast, the question is on how to achieve scale for battery recycling.
Yeah, so we're students of our own history at Aqua Metals on that front. And when we built the lead recycling technology that was the alternative to smelting, one thing that we learned was you shouldn't go from a bench scale or lab or bench scale to a full-sized plant. And as I like to joke around and say is, what could go wrong? And one of the lessons that I learned within Aqua Metals was our former chairman of the board was a high-level person at Chevron, Shark Yousafzai, and he brought out a gentleman named Jeet Bindra, who is a former global manufacturing president for Chevron. So this is an oil and gas plant, chemical plant builder coming out to witness what we were doing, and he said at that point in time, he's like, next time around, you guys should really do lab scale to bench scale to pilot plant to demonstration commercial facility to modest commercial facility to the massive plant. And that's truly how you scale and debottleneck and learn each step of the way. And so that allows us also as a benefit to be really good stewards of the capital and make sure that we get the TRL, or the technology risk level, to where it needs to be at each stage gate. And that's how we embarked upon the lithium program for lithium refining, is to do that. And so what we've already accomplished is lab scale, bench scale, and now pilot scale. And we're the only company that's continuously operating a lithium-ion recycling facility. And so we feel like we're in a good position there. The next step is that 3,000 ton per year phase one of our campus environment, which would be what I would characterize as a commercial demonstration plant. That's worth 60 million plus of revenues, which would be great, as Judd was mentioning, to help fund future growth. And then the next step from that is to get to the 10,000 ton, which gets us to 200 million plus revenue opportunity, and then beyond. Other scaling opportunities for us include partnerships. So as we begin to announce and reveal who our commercial partners are, both from a feedstock perspective as well as an offtake perspective, there's a lot of black mass producers that are interested in monetizing the go forward to the cathode active materials that we could partner with and get synergies by co-locating our technology and scaling together at one of those facilities. Now on the back end of what comes out of our process, taking these metals and turning them into salts is interesting. And so like I showed you the picture of the nickel and the cobalt earlier, this is nickel sulfate. And that's what's called a PCAM, or a pre-cathode active material. And this is a cobalt sulfate. So that we have partners that we're looking at working with to take our metals and take these to the salts and then ultimately make the brownie recipe for each individual battery cell manufacturer. That creates synergistic scaling opportunities that also are really good for the climate and the environment, because rather than ship all these materials around to certain specialists, there's going to be some consolidation of where all this kind of begins to take place. And that reveals for us great opportunities in joint venture and partnerships.
Thanks.
Talk about just help us think about the CapEx requirement of your technology versus the ones that currently exist in the market today, and then also bring in the environmental footprint of your process, of how, does your process cost more but more environmentally friendly? Like, just help us think about it.
Sure. Yeah. That's.
Just to rephrase the question. Yeah, rephrase the question. The question is on CapEx and environmental footprint versus other technologies.
So I'll start and then pass it to Judd. So the environmental benefits of our process, if you compare us to a pyrometallurgical world, the carbon output is infinitesimal compared to the smelting environment. So the environmental impact is vastly reduced. If you compare lithium refining to hydrometallurgical processes that are out there, we use about 1/200th of the chemicals and create 1/200th of the waste streams because of that. And that's carbon waste streams as well as materials that go into the air, land, and sea. So the environmental is something we kind of Pareto charted out to begin with, is like, how do we solve for environmental and economics? Now, the benefit of not creating waste streams is that you don't have to manage the cost of disposal of those waste streams. And so those were where the economic impact is really great. Hydrometallurgical creates a byproduct called sodium sulfate, and it's actually more than a ton of sodium sulfate per ton of materials that's produced. And so you could almost argue that they're pollution factories with a side stream of creating some valuable materials. What we do differently is not create those waste streams to begin with, because we recirculate within our process the chemicals that we do need in our own closed loop, and we don't have to spend the CapEx or the OpEx conversion cost to deal with all these chemicals one-time use and waste streams one-time dispose of. And I'll ask Judd to comment on the CapEx and the OpEx differences compared to other ways of doing it.
Yeah, no, when we're looking at the CapEx for a plant our size, to generate the $60 million in revenue, that the CapEx required to do that is probably about $25 to $30 million. To generate about over $220 million of revenue, the CapEx would be an additional $70 million to do that. And we could do that in a location as little as 5 acres. What we're seeing from others who are trying to do it at a different approach is more than $100 million to do something similar, probably $200 to $300 million or more, just because of the footprint and the different things that they need. The other point, and it kind of relates to the question earlier about scaling, is our process is modular. So what we're doing at a pilot scale is something that we just modularly increase to do at a more of a demonstration scale. So once we've got the technology in our pilot scale proven out this year, we'll be able to put that and scale it into our new location. So we're looking at, from a CapEx standpoint, just a lot lower CapEx that generates a good return on investment. Also, because we use less chemicals, our costs are significantly lower. There's some studies that were published by Goldman Sachs and others that talked about what they think that OpEx would be, and we were significantly less than what they thought that it would be for the recyclers out there.
All right. So I guess running out of time here, but maybe one last question from me on the business model. You had a slightly different business model under the lead battery recycling, and today. Could you just talk to like what lessons have you learned from there, or what changes have you made since then?
Yeah, so that's a lot of lessons we've learned from our venture in the lead recycling business, which is actually an equipment supply and licensing business today. Our first licensee happens to be in Taiwan, which was just deployed in the third generation of our lead refining business last October. So that's a commercial, visitable demonstration showcase facility for those that are considering, hey, maybe we shouldn't smelt lead anymore, maybe we should do a cleaner way of recycling the lead acid batteries. But that business model was always intended to be a capital light model for Aqua Metals, to get the product proven and then productize it and then license it, because that's an existing industry that needs to upgrade. Now, when we look at the lithium industry for recycling, it's a brand new nascent industry that needs to be created. And so that's why we chose the different business model for the lithium space, which is to truly be an operator and a recycler at our core level of business. Now, that said, as I was mentioning earlier, with black mass supply partners, as well as offtake salts and cathode active material, and cell manufacturer partners, et cetera, there's opportunities for the company to go beyond just input processing, output operating, but joint ventures, co-locations, potential licensing of the technology in areas that we think it makes sense to consider licensing. And we've built that organizational capability in our past to be able to do those different types of business models. But our primary core is to be the recycler.
Perfect. And then I know a couple of seconds left here, but anything, the closing remarks for this energy audience on the lithium-ion battery recycling industry?
Yeah, so I would say, every time you wake up in the morning, you see a new story about the dance cards of who's partnering with who. And I think there's going to be a lot of continued investment in the private sector as well as the government sector, and a lot of consolidation ultimately in this industry. There's going to be technologies that are promising that don't work. There's going to be companies that have technology that works that don't tend to their capital as well as they could, and ultimately we'll see consolidation. But we're entering into an era right now with the electrification of more investment into infrastructure, into a new industry than I think any of us have seen in our lifetimes. And that's what makes it really exciting for us and all the other players that are in this space. And it's a space to watch and be a part of. And it touches all of us. I mean, how many lithium-ion batteries are we tending to and charging? I have to go remember to charge up my ski boots for my next ski trips. So it's like you got to have your boot heaters, and you got to have your cell phone, and you got to have your leaf blower, et cetera. So this whole electrification of the world is a space to watch.
Absolutely. Well, no, thanks a lot, Steve and Judd, for coming over here and talking about lithium-ion batteries and recycling.
Thanks for having us.
Yeah, thank you.
Appreciate it.
Thanks, everyone over here.